Hello, my name is Andrea Valenzuela, and this is how to hook up and operate the armatrol Mark II robot. For this project, you will need an armatrol Mark II robot that has been rewired to work with LabView, a 12-volt battery, a robot platform with a crio and matching hardware, LabView software and all associated project files that go with it, driver station software, PWM cables, power leads from a power distribution board, an Ethernet cable, 2 Attack-3 joysticks, and a stop button. Introducing the armatrol Mark II robotic arm. This thing is pretty cool. It's got 5 motors to operate. I am using 4 Victors and 1 spike relay to control them. It's also got 4 potentiometers, which means it can get pretty accurate if you want to program this thing autonomously. Also, everything is labeled beautifully, so you shouldn't have any trouble getting this thing to work. Just follow these instructions and you should be good to go. Let's get started. I will be using this robot as a platform to showcase the armatrol Mark II robot and how it's connected. This is a power distribution board. Make sure yours has fuses wherever the power is coming out of, because if it doesn't have them, it won't work. On the other end of these, we have these nifty little quick connects. Now the standard on these is that the orange side goes towards the power and the white side goes towards the load. So that's where your motors are, where your speed controllers are. These quick connects can go any way. It doesn't really matter which goes where. Just make sure that they're plugged in the right way. For example, this is the wrong way. Just flip it over and it'll be the right way. One more. There we go. We're all set for power now. This is a digital sidecar. It's how our motors talk to our crio, basically. All the PWM cables are put into the appropriate slot. For example, PWM3 is in the 3rd slot, PWM4 is in the 4th slot, etc., etc. The only one that's any different is the relay, which is number 7. It goes on the far side here, and it goes into relay slot number 1. These here are the Victors, and this is what those PWM cables from the sidecar plug into. Now the way they plug in is that the white cable faces the outside of the Victor and the black cable faces the inside. Once again, that's the white cable on the outside of the Victor, and the black cable on the inside. Now these are all quite nicely labeled, so make sure the right cable is going into the right Victor. That way everything should work perfectly. Oh, and I can't forget about the spike. The spike plugs in exactly the same way, with the white wire facing the outside and the black facing the inside. Now you might be wondering, why do I have this one spike? Well, it's for the claw at the end of the arm. It doesn't need a Victor. A spike does just fine in this case. On the other side, there's 2 more Victors, and you plug these in just like I said on the other side. Make sure when you're plugging these in that you push them in very well. Sometimes they don't make a good connection, and it's very frustrating when you're troubleshooting and you're going crazy, and all it is that this little PWM cable is not in all the way. So make sure it's good the first time. Now we can go ahead and plug in the battery and switch on the power. So it's not that red button, it's the little flicky thing at the side. Very deceiving. You can see the lights are now on the Victors. They're blinking. This is a good sign. This is a tethered demo, so we're going to plug the Ethernet cable from our computer into the crio's number 1 slot. We're going to have to control this robot with something. I chose 2 Attack-3 joysticks. We got plenty of these in the classroom. The left joystick is going to go into USB 1, which is the front top slot. And the right joystick is going to go into USB 2, which is the bottom front slot. You're also going to need a stop button, so make sure this thing is plugged into the back of the computer. Doesn't matter where, it just has to be there. Okay, the robot is almost ready to go. Everything is wired up. It's got power, it's got signal. Let's open up LabView. So we're using LabView 8.6 FRC edition. We're going to want to open up a project called armatrolsetup.wmv. That means LabView project. We're going to wait for our Project Explorer to open up. Here it is. Under RT Crio, target, expand it, armatrol2.vi, right click open. Hope you got all that. Window, show block diagram, and here is all of my pretty code. We're going to go ahead and run this. It takes a while, just wait. You'll have your functioning robot soon enough. It'll be worth it, I swear. Alright, so the code is now on the robot. We can go ahead and open up an instance of the driver station. Green lights mean go. We have communications, so go ahead and click enable. And now if we move our joysticks, our robot should move, and hey, look at that, it does. Congratulations, you now have a functioning robot, hopefully. And have fun. I'm just going to do a quick little demonstration so you guys can see that this thing actually is useful for something, kind of. I'm going to move these little 9-volt batteries around and then stack the whiteout on top of it. You may notice that when I go side to side, it kind of sways and bounces. That's because instead of a belt, like it should have, I use an elastic band because that's all I had. The belts that came on these things were so deteriorated, they were just hanging on by strands. I'm going to be quiet now, and you can listen to the sweet windings of electric motors. So this is the end of my video tutorial. I hope you've enjoyed it. Don't think that the work for this robot is done though. It still has potentiometers that I haven't even programmed yet. So feel free to tinker with the code, rename the file, and just play around with it and have some fun. Alright, bye guys.